Okay, so generating sequences, we're going to have a quick look at. Question 4, you've got the nth term of some sequences are given below, and you want to do the first 5 terms. So I'm going to focus on this one. You've got 5n plus 3. Now 5n plus 3, 5n is your 5 times table, and then the plus 3 means you're going to be adding 3 to it. So the different ways you can do it, you could literally write out your 5 times table, 5, 10, 15, 20, 25, because you want the first 5 terms, so term 1, 2, 3, 4 and 5, but we don't want the 5 times table, we want to add 3 to all of it. So 5 plus 3 is going to be 8, 10 plus 3 is going to be 13, 15 plus 3 is going to be 18, then 23, then 28. So that is the first one done. Question 1a, that is our sequence. Now the good news is, if you've watched the nth term videos, we can check and make sure that makes sense. So I'm going to write the numbers again, 8, 13, 18, 23, 28. If I look at the difference between those terms, the difference between 8 and 13 is that you add 5. The difference between 13 and 18 is you also add, you add 5, and so on. So the whole way across there, I'm adding 5. This is the part that tells us that it's acting like the 5 times table. Now we know that the first term in the 5 times table is 5, so I can write that above it, and the second term is 10. We know that that is not the 5 times table. The difference between 5 and 8 is 3, so it's the 5 times table with 3 added on, 5 times table, which is known as 5n, with 3 added on. So you can actually go back and prove that you definitely generated the correct sequence. I'm just going to pick another one as an example. So I'm going to have a look at C. So I've got 3n minus 2. Let's just write that down. 3n minus 2. So the 3n part is telling me it's the 3 times the table. So 3 times table, and then I need to take off 2. So same technique. I'm literally just going to write down my 3 times table first. The first 5 terms, 3, 6, 9, 12, 15. I don't want the 3 times table, I want to take 2 off it. So the first number is 3, 3 minus 2 is going to be 1. 5, I've got 6, I want to take off 2, so 6 take off 2, it's going to be 4, 9 take off 2, it's going to be 7, 12 take off 2, it's going to be 10, and then 15 take off 2 is going to be 13. So that would be my sequence. Now that's me trying to make the maths as easy as possible. That doesn't mean to say that's how everyone's been taught. So I'm also going to talk through that second example, so the staying with, let's just change the colour but just use it again. So I'm staying with 3n minus 2, and I'm just going to talk through another option which you may have been taught. 3n, this bit here is saying it's 3 lots of whatever n is and take off 2. Now to generate the first 5 terms, n just keeps changing. So if n, to get the first term, n is 1, so that's 3 times 1 and then take off 2. So 3 times 1 is 3, take off 2 is 1. So that's why we got our first term to be 1, because our first term is 1. I'm now going to change n to equal 2. So it's 3 lots of n, so it's 3 lots of 2, then take off 2. So 3 lots of 2 is 6, and 6 take away 2 is 4. So that's the second one, and you can see why it's there. And then you can carry that process on to generate the rest of the sequence. So when n equals 3, 3 lots of 3, take off 2. So 9 minus 2 is 7. Now as you start to write that sequence out, 1, 4, 7, you should be looking for patterns as well. So the difference between 1 and 4 is you add 3, the difference between 4 and 7 is that you also add 3. So you can start to then use a quicker method to actually use the sequence to fill in the missing numbers by just using the patterns of add 3, add 3. So that's your generating sequences. If you want to practice any of those, I can zoom in, and there are a couple on there that we haven't had a go at. Feel free to pause it and have a go.